Good morning. The time is 8:31, and I am delighted to call to order the August 31st, 2022 CSLB's board to welcome the Nevada State Contractors Board to San Diego, California for our 13th annual joint meeting. CSLB and California consumers have significantly benefited from sharing ideas and strategies with our Nevada colleagues. Our former licensing chief has reported that he had Nevada licensing chief on speed dial to discuss applicants and various licensing procedures. And our two executive officers regularly meet to discuss mutual concerns and share ideas. We all know it's beneficial when we don't have to each individually reinvent the wheel, so I'm very appreciative of the opportunity to share experiences. We will learn more today about the multi-state enforcement operations in which Nevada and California lead. Nevada Board Chair Boyd Martin and I will rotate the introduction of agenda items, and I will now turn it over to Nevada Board Chair Martin to open the Nevada Board meeting.
Thank you, Chair Teichert. Board. I'm Boyd Martin, as previously mentioned, Chair of the Board. Before we begin today's discussion, I wanted to take a moment to recognize the longstanding partnership we've had with California Contractors State License Board. For the last 13 years, our boards have remained committed to working collaboratively and on shared goals and objectives, which help guide our own directives to address and respond to changes in the construction and economic environments in our state. We are grateful for the opportunity to continue learning from information on the operations, policies, and innovative solutions being implemented by your board, and for the ability to share our own experiences and strategies with you as well. This collaboration is unique among Western states and has proven beneficial in many ways for our agencies. On behalf of Nevada State Contractors Board and Executive Officer Green, thank you for always being a valuable resource to Nevada and for your willingness to work together on significant matters of importance to us. Turn the time back over to you.
Thank you. So if we could all please stand. I will now note for the record that Rodney Kobos and Jim Ruane have an approved absence for today. And I would also like to pause on recognizing Jacob Lopez. He was appointed by the CSLB by the Senate Rules Committee in July of 2022, so he's a new member that we didn't call out sufficiently yesterday. Jacob is the executive board member of the Southwest Regional Council of Carpenters, representing more than 63,000 members in Southern California, Nevada, Arizona, Utah, New Mexico, Colorado, Eastern Washington, Idaho, Montana, and Wyoming. Mr. Lopez's term continues through June of 2022, or potentially much longer than that.
I think it's a great privilege and honor to be part of this team, and I look forward to being looking at all you all, listening to you yesterday. I appreciate everything that everyone does for our people that we represent, and look forward to working with each one of you. Thank you.
Thank you. Welcome, Jacob. So, Mariah, could you please confirm the California board member attendance and call roll? And also joining us at the table is Registrar David Folk and Board Counsel Joe Chin.
Actually, if it's okay with the chair, I'm going to call roll for the California board. Tori? Here. Miguel Galarza? Here. Susan Granzella? Here. Alan Guy? Here. Jacob Lopez? Here. Diana Love?
Here.
Michael Mark?
Here.
Steve Pinelli?
Here.
James Ruane has an excused absence. Johnny Simpson?
Here.
We have a quorum.
Thank you. And then Nevada Executive Officer Margie Green will call roll for Nevada.
Good morning. Thank you. Please note for the record that Ms. Calvin, Mr. Leggett, Mr. Menzies have excused absences today. Member Cowart?
Here.
Member Hernandez?
Here.
Member Martin?
Here.
Member, and that's it. Member Lay is also excused. I'm sorry.
Thank you. So we'll move to agenda item B, which is for public comment and to request agenda items for future meetings. The boards both value public input as part of our consumer protection mission. To allow us enough time to conduct our full schedule of business today, I'm limiting public comments to 3 minutes apiece. If your comments don't involve an item on today's agenda, this would be the time where you can make them. If you have comments on one of our agenda items, we encourage you to wait until we get to that item. We will give you the opportunity to make comments at that time. We also ask that your public comment relate to the agenda items currently before the board. There are a few other rules that apply. First, California law prohibits board members from discussing any matter brought up during public comment, and board members are not allowed to act on any item not on today's agenda. Second, if you want the board to discuss a topic not on the agenda, you can ask us to consider placing that issue on an agenda for a future meeting. And finally, if you have an application, complaint, or disciplinary charge pending before the board, we ask that you not discuss the details of your case or pending complaint. That's because board members may be the judges and by law are not permitted to receive evidence or information that is not part of the administrative record in the case. Are there any comments from the public? Okay, seeing none. Do any board members have any item they would like placed on a future agenda? Okay, and I'll turn it to Chair Martin to call for Nevada public comment.
The same rules apply to Nevada as noted by Chair Tykert. Are there any comments from the public? Seeing none, I'll turn the time back over to you.
Okay, so we'll begin with a presentation by Jeff Beavers. It's my pleasure to welcome Jeff Beavers. He is the Executive Director of the Network Integration and Services for the National Electrical Contractors Association, and will provide a presentation on new and emerging technologies in the low-voltage solar industry.
Good morning. I'm glad to be here. Thank you for the opportunity. And you're definitely spoiled with great weather out here. I came in from Kansas City, and it's probably 100 degrees, but it's going to turn cold and icy soon for about 6 months, and so it's fantastic to be here. The sun does good for the mind and the body. Thank you. Thank you. You got to talk right here. You betcha. Thank you. Yeah, thank you. Yeah, there'd be tight, your neck would be stiff if you had to turn your neck for the whole time. So thank you for the opportunity to be here. And we're talking about telecommunications, but we use convergence, tactile internet, because in our industry, we used to have a long-range plan, would be 20, 25 years. Now we're talking 5 years because of the constant and rapid changes. How's the audio? Am I good? Not too much feedback? I'll move a little closer. Okay. Yeah, so this was approved in June. I don't know if you're familiar with this, NRIDE. I know in Phoenix and San Francisco they have Waymo, a driverless car service, relying a lot on the network. The network is what we call the same network we had in the 90s and 80s. It's the one that drove our telephones and fax machines, and we had broadband, but it's just another application on the network. And so this is approved for public streets, fleet vehicles. As you know, the trend with electric vehicles, the progression is autonomous vehicles, and this one's completely driverless because there's no room in the cab for a driver. This company is adopting it for fleet vehicles where they have a predefined route that they're able to map it out. They have a driver that's remotely positioned that they can monitor up to 10 vehicles and take control over the vehicle if need be, right? So it's like a remotely piloted aircraft, except it's on the city streets. So that's happening right now, but it's creating a huge demand on our networks. And I say the network that's inside the building, outside the building. It's connecting to 5G, but that 5G is connected to fiber optic cable that goes to a data center that goes back to that building over your cabling inside the building. So it's all connected, part of our ecosystem. And it's amazing how quickly we got here. Just 20-something years ago, Netflix was founded, right? They used to send you a DVD to your house. Now Netflix is 50% of global internet traffic. And it's streaming on any platform that you could think of, right? From a mobile device to your big screen TV. You could log in at the hotel and get Netflix just in 20 years, right? And we had the advent of DSL and cable modems to our houses, right? And then now we have everything's connected. If you were a contractor, let's say 20 years ago, a builder might say, why am I going to put any cabling in his house? Because everything's going wireless. Because again, 25 years ago, we had the first wireless router. Who would have thought we'd have pet feeders on our wireless network today? And the last 2 years with the pandemic, with mom and dad and the kids working from home, that's quite a demand on the network. I had 2 girls in college, and they would constantly say, can you get off the Wi-Fi because I have a Zoom class, right? Because it was poor connectivity. But in my house, I have wired and wireless. My work computer's plugged in. I have a smart TV that's plugged in. And so that was pretty short-sighted, I guess, in the like for a builder to say, we don't want any cabling because everything's going wireless. Well, the future is going to be, it's not either or, it's both. So, by the way, what do you think is the average number of devices? What do you have in your house? I mean, not just your mobile devices, your tablet, your PC. You have smart TVs, the Roku boxes. We just bought 3 new appliances. They all have Wi-Fi connections on them. The average in America is 16 devices on the network. Their network. That's just an average home. Some people have over 50. So we have smart homes not on purpose or by design, but by virtue of the products we buy. And so, I mean, couple that times however many households and buildings you have in America, globally, and it's part of a connected ecosystem. By the way, home health care, we'll talk about that later, is another application. And post-pandemic studies show that it's 37 times greater of using telemedicine. And that's going to be a demand on the network in appliances at home. The U.S. government defines the telecommunications. They recognize this as a critical infrastructure. It enables the function of all other industries. I mean, you think about agriculture, energy, finances, the DoD. Without communications, how could they function? I mean, our future wars are going to be cyber, right? They're going to be cyber attacks, so they take out your communications and you cannot function. Hey, you can't function if you can't do banking transactions. And that's happening over the network. And so it's just in a short amount of time, it's no longer an amenity, but it better work. And it better be ubiquitous, right? It's not just a nice to have, but it's a must-have, again, for healthcare, work, school, and beyond. We're part of this connected ecosystem. The FCC has initiatives for not just rural broadband, but to recognize access to information, and that's connectivity, is an opportunity for many folks to break the cycle of poverty. It's education and access to it. So real quickly what we do, it's not just telephones and fax machines or cable TV. ICT is this umbrella of information and communications technology. It's a global term. And if you come from the IT world, right, it's computers and the systems that drive it, printers, copiers, fax machines, cable TV, that's IT. The OT was part of your building systems, building monitoring, operations, right? Access control, emergency responder, radio communication systems, fire alarm, public address, mass notification, lighting controls. If this was a hospital, you'd add nurse call and on hospital systems. Those are operations technology, usually bolted down, have a longer lifespan. But from the late 90s, we had this thing called convergence, right? When Cisco entered the world with a voice over IP telephone, it's no longer telephone dial tone from the phone company. It works off your data network. And then soon we realized, okay, well, it's neither voice nor data, it's just data, so it's just another application. So that converged all those systems onto one network. But the progression is with IP and the Internet of Things, is that convergence includes OT, nurse call, building automation, lighting control. All those things now are on the network, the data network. Some of the trends, you probably heard of this, PoE or power over Ethernet. Again, this same data cable it delivers power, right? There's 4 pairs, 8 conductors, 2 pairs for transmit and receive. The other remaining pairs are delivering power to your devices. Imagine you had a wireless access point and you want to put it right up in the middle of the ceiling for the best coverage, but you didn't have an electrical receptacle there. You either had to pay to have electrical receptacle there, or you put the access point where the electrical receptacle is. But as technology would advance, you could power that thing directly from your data switch. So now that data cable also powers that access point. It could power a telephone, it could power a camera, and you see the advancement of increasing of watts. You could do a point tilt zoom camera, access control systems, and it progresses to where you have point of sale systems, LED lighting, nurse call systems, and it continues to go up until 90 watts. Eventually, your TVs could, be not just a smart TV to get streaming content, but you could power that TV from your network switch. That's the progression of power over Ethernet. Digital signage, you're going to find that for wayfinding. Emergency lighting now, the NFPA recognizes PoE as a technology, and they have some guidelines for even putting your emergency lighting on PoE, power over Ethernet. This is a building, Bixby headquarters in Tampa, Florida. It's 100% PoE lighting. If you look at their racks on the top right, the cabling and that access panel in the ceiling, it looks like any other telecommunications system, voice and data, but except it's delivering power for the lights. And it's inherently efficient. You have less cabling, less fuel load in the ceiling with less cabling, and it's on the network, and you have access to it on your phone, right? You can monitor occupancy, the data, and you could tailor the usage of those things and tie that into building systems. So it just opens the door for other efficient technologies. So power over Ethernet and PoE lighting is happening today on the networks. And then here's another cool thing. Since you have a data cable there, why not turn that light fixture into an access point? So instead of using radio frequency, you use light. So it's a fairly new technology. It's a couple years from being accepted. The U.S. Army has spent about $20 million for a test bed for this. Because look, so unlike radio waves, this won't go through the walls. So it's inherently secure. So there's some applications for that. Manufacturing is looking at this potentially, possibly if you're doing a combustible environment where radio frequencies could cause an explosion. Light fidelity is one of those applications. So really it's just for awareness of what's out there in case you have contractors looking at this, hey, do I need a permit for something like this? It's a light-fi is happening, and people like Philips Lighting, right? One of the largest manufacturers of lighting has their product to do this. And it's very dense because with the number of lights, it allows a lot of users to access that. Okay, the code recognizes this. The top is off, that's okay. On the left is excerpts from the 2017, and the right is 2020. They recognize the constant growth and maturity and advancements of power over your data cabling and power over Ethernet. Right to the left, you see that highlighted. It says the conductors that carry power should be copper, and it recognizes the current carrying capacity of the connectors. And there's an informational note that says the 8P8C connector. Have you all heard of the 8P8C connector? Probably not. That's the connector on your plug on your cord. That's the 8P8C, right? That's what it's talking to, your data cabling. Not just the cord, but up in the ceiling. And the code also says, hey, bottom left says 725.14. That's your tables for your bundling of power. It called it data cables. The next cycle said, no, we need to be more specific. That's balanced twisted pair. That's your category 5E, category 6. Again, it's this cable. So they're telling you it's this cable that we all know and we have in our houses. It's now delivering power. And here's some guidelines. It has to have some recognition of current carrying capacity, right? Again, balanced twisted pair. Our 8P8C is also known, you've heard of it as an Ethernet cable or an Ethernet outlet or an RJ45. RJ45 is just from the telephone heritage registered jack when we used to order service. That's where that came from. Kind of like Xerox is to photocopy, RJ45 is to the 8P8C. But you should be able to see cut sheets on the products for the cable and connectivity that reference these standards for the capability to deliver power. Hey, if it was just fax machines and analog telephone, you could do that all day long, but now there's some new requirements for our systems, right? You could buy jacks like this and cabling all day long. It says Cat 6, it says compliant. It's hard to find specs on the capability to deliver power for PoE. The NEC also referenced bundle sizes. Why is the bundle size of your communications a big deal? Because now it delivers heat, you have heat dissipation. So bundle sizes could cause issues there. Over the years, we've had counterfeit UL listings. right? So the UL had to come up with, UL listings for like plenum versus riser cabling, for example. They had counterfeit UL listings. So they've had to put some holographic type of packaging that's hard to counterfeit, right? So there are some watchdogs in the industry that look at that. And a lot of those not only had counterfeit plenum or riser stenciling on it, they had copper-clad aluminum versus solid conductor. Remember, the code says they must be copper, but you'll find some copper-clad aluminum data cable out there, and that's not going to deliver power. In fact, TIA 568.2 is the basis for which manufacturers, manufacture cable and connectivity. They added this thing in here to combat, or to make that clear, copper-clad aluminum is not allowed. So the structured cabling system is also a term. Structured really just means there's a hierarchy. You have backbone cabling, building to building, backbone cabling, building to telecom room, and horizontal cabling from the comm room to the outlet, right? That's horizontal cabling. That cabling system is non-application specific, meaning telephones, fax machines, streaming cable TV, whatever the application is, it could deliver it. But I think the application for the future, you have to assume it should be power over Ethernet. We already saw all the applications and devices from a telephone to a TV. We have to assume power will be there, and we need to look at the current carrying capacity, right? The standard also recognizes a direct connect. So 20 years ago, typically all we had was a work area outlet about 18 inches above the finished floor at a desk for a computer or a telephone. But now you have stuff in the ceiling. You have building automation systems, access control, cameras, where it's only ever going to be a camera. So they recognize this need to, you don't need a work area outlet, just put a direct connect. You could also, that top right, you could also buy those connectors all day long. But how do you know that they're made for stranded or solid conductor? The cabling in your ceiling is going to be solid conductor, but if you crimp those on, it's made for a stranded conductor. It's not going to work over the life of the system. So the standard says, hey, we need to address this. It makes sense. They call this thing a modular plug terminator link. It's manufactured per 568.2 and also has the current carrying capacity ratings per the NEC. So that's out there. Makes it efficient. So here's another trend. Perhaps you've heard this, digital electricity, which is actually a trademark from Volt Server. It's fault managed power. Have you all heard about this or seen this? It's currently installed as class 2. This probably the early days of this saw this powering devices on top of a cellular tower. Imagine there's baseband units up there. How do they get power several hundred feet up in the air from their site? So they were using this, so they were delivering power. And this could do, again, 2,000 watts over 2,000 meters. Verizon has this. I saw this at their Heinz Field in Pittsburgh, where they're deploying 5G antennas. And as you know, football stadiums are enormous. They're delivering power to those antennas from one central location over this fault-managed power. Sinclair Hotel has PoE and digital electricity, and I think they're the first building to use a lithium-ion battery instead of a diesel generator. They're also building Marcel Hotel in New Haven, Connecticut. It's reported to be the world's first net zero hotel. It's also using this technology. The code recognizes this, so they're going to put this in the next version of the National Electrical Code. They're going to call it fault-managed power under Class 4. And unlike a lot of electricity, it doesn't require conduit. So that's also a culture change in many cities that require conduit for everything. So here's how it works, right? You have your traditional AC comes in from your transmission distribution lines, and once it enters the building, it's converted to DC. It can operate over your data cabling, your Category 6 cabling, but as we know, you have a 100-meter length limitation on that structured cabling, so they can convert to a 14-gauge wire, and you couple that with fiber optic cable, you can power devices. I mean, imagine a multi-campus building, or you have a parking lot with security phones that are IP-based. You can power that thing from your building a couple thousand meters away, and it's safe to touch, because what it does is that it takes the power and it splits it up into packets, so several hundred packets per second, but it's also sending data. So as soon as it sees a fault within a millisecond, it's going to shut the system down. And millisecond, I mean, the human reaction is probably a couple hundred million milliseconds. This is how fast that is. So imagine like instead of a high-pressure water line, it's got millions of water droplets. That's how they describe it. So that's it's pretty cool. The building owners look at this because over the life of the system, sustainability, less cost, less equipment, and about 80% reduction in operating cost, and it's more efficient with your AC to DC conversion. So that's happening right now. Warehouses, large venues, stadiums are already seeing the need for that. A couple of things happening to the network. A client told me this is they expect to have 100 gig of the desktop in 10 to 20 years. 100 gig, you know what that is? That laptop there and the laptops you have at home or your work is automatically capable of 10, 100, 1,000 meg. 1,000 meg is 1 gig. That's 100 times more than probably most computers in the world. Have you heard of 100 gig yet to a desktop? They're talking about that. And this other client says, no, we're not going to do 100, but 10 gig is more likely within 5 years. And this is the DoD, so the early adopters of technology. What they have there often finds its way here. I mean, the DoD is the ones who created the internet. So 10 gig, look, where does that happen? So Corning, the largest manufacturer of fiber optics in the world that other manufacturers use, they forecast this. We're already seeing 10 gig almost bypassing what the copper cabling can do, right? We've all heard of 4K and 8K video. Augmented reality, virtual reality is going to happen, and that's going to require high bandwidth applications. Wi-Fi 6 is ratified in 2020, and of course we know 5G, we're building out networks for 5G. A lot of that's not going to be for, I mean, yeah, we might use that on our mobile phones, but the biggest users are going to be like autonomous vehicles, and then fixed wireless. But they're already looking at Wi-Fi 7 and 6G. We're still trying to figure out 5G. But look at these applications, the partial hologram, tactile internet, and we'll get into that. And the hologram, these are the things that they're doing. Imagine a virtualized battlefield to where it's real time, right? Those are just some of the applications that are driving what we're going to find in the public sector. So here's the tactile internet. I'm going to focus on the bold items, but basically it's ultra low latency, extremely high availability, ubiquitous, right? You want to be you want it to be streamless. When you leave your house, on the road, when you get to work, you have constant connectivity, right? And once you get in the hotel, if you don't have cellular, you say, what's the hotel's Wi-Fi password? So you could have constant connectivity. That's what high availability is going to do. Reliability and security. We're not going to get into cybersecurity, but that's what that's going to be. There's going to be over there right now. There's a forecast for 65 billion things on the network in a couple of years. I mean, if the average house in America has 16 devices on the network, imagine that compounded with commercial buildings, smart cities. So it's ripe for nefarious activities in cybersecurity. But that's not for this discussion. So latency, real quickly, latency, this book, I don't know if you read this book. They were using automation to do trading on Wall Street, and they were cheating, basically, and they were willing to put the banks wanted their servers as close to Wall Street as they can to get the edge in latency. That's just time. And they were willing to build their own network, $100 million fiber network, just to make it as straight as possible. But that's where we got the term co-location. Like in data centers, they wanted their equipment as close as possible. So financially, look, Amazon and Google will tell you 100 milliseconds loses them 1% in sales. 1% in sales for Amazon is an enormous amount. For us, with protection, substation communication, right, smart grid applications, they're migrating from microwaves to fiber just to reduce the latency, which, like a millisecond can make a difference in if a relay closing or not. So it's a life safety issue. And the bottom line, at 5 milliseconds or less, it's going to allow real-time applications, right, that self-driving vehicles, and that V2X, that's vehicle to vehicle, vehicle to structure, or vehicle to human. Imagine a self-driving car sharing our public roads, and you got people in the crosswalk. It's got to have that expected latency to have the appropriate response time. And human to machine, We just saw that with that fleet vehicle, with a remotely monitored and driven vehicle, but we're going to talk later about human to like doctor to robot on the network, to like doctor to robot on the network with remotely performed surgery. Oh, let me back up. Okay, the tactile internet is going to enable in real-time control of the Internet of Things, right? Human to machine interaction and haptics. You recognize haptics even though you may not know what that is, but on your telephone you have haptic settings, right? So you can get, instead of a ringer, it vibrates, you can set your keyboard to have some feedback, right? That's what haptics is. Imagine doing that on the network, where where part of your data includes the sense of feel, and it's an immersive environment, and what that opens the door to. We'll talk a little about haptics later, but look at the next thing with holograms. When Zoom gets boring, now you have something like this. Partial holograms. Just another step in engagement and immersive interaction. The WeWork company, you've heard of WeWork, right? They're rolling this out as a test bed to do virtual, I mean, as CEO, now it could be at multiple places at one time. So that's happening. That's taking max headroom to the next level. Max headroom without the latency and jitter. And it's happening. Holographic communications, again, like I said, the remote healthcare and telemedicine is 38 times greater than pre-pandemic. They're going to use this opportunity for holograms for consultation, right? Doctor to doctor with consultation, business communications. Again, interaction with the point of sale displays. Our displays are going to be not just 3D, that you don't need the 3D glasses, but you'll be able to do something like this. You can go to like Zenni Optical, for example. If you bought eyewear, you could upload your picture and try on glasses. This takes it to the next level. You could do virtual shopping, try on some clothes, and it's a whole new experience, but that's what technology and a low latency network is going to allow you to do. It's going to allow this. I mean, you probably saw this with some Meta advertisements where there's a physician with apparatus on their fingers and they're doing things on a screen. They're testing that out with Meta. But to be able to do this, to have again, not just a virtual dressing room, but imagine you have a sense of touch from afar. You could do a virtual handshake, right? You could feel a hand grip. That's pretty cool stuff. How about high-risk applications with, let's say, mining? Now you have you send a robot down there, and that robot gives an operator in a safe environment the tactile and haptic feedback about the environment down there. In education, we're already seeing this in our trades, like to be able to climb a utility pole. You used to take a 2-pound hammer, you hit it, and the sound and feedback told you if it was rotting or not. You could do that remotely now with you get that tactile feedback in a glove. It says, oh, that kind of feels like hitting a hammer onto a pole. So that's changing our learning. But one of the adopters of this is telemedicine. Again, 38 times greater than pre-pandemic just for telemedicine. And we have robotic surgery already, right? What's the name? Da Vinci has that. But right now, the doctor's here, the robot's right here. They're doing it. The progression is on the network. Now you could do it far away. Robotic assisted surgery, right? The doctors will wear some apparatus, headgear, or gloves to where they manipulate the robot. So this is it. Long distance proof of concept. So that's made possible with haptics. And how can if a surgeon know if they've gone too far, right? Your doctor will say, now tell me when this hurts. You can't go, tell me this hurts, one Mississippi, 2 Mississippi, right? It's got to be that very low latency with that haptic feedback to where they know they're replicating the human. So the physical media, well, I hope I'm not taking too much time. We'll wrap this up. The physical media is what we're going to focus on with network latency. Latency again in IT. If at ITs, you could just refresh the screen. In operations technology, you don't have time to refresh the screen, right? And you have latency by packet loss. A lot of that packet loss is impacted by your cabling, a poor cabling. If they can't send it, there's a request to send and that retransmission, right? It's fast, but if you have to retransmit it, it's latency. It's like when my wife and I are driving and she says there's a deer in the road, and I say, what'd you say? She says, there's a deer in the road, right? That's a retransmission. That's a killer for operations technology applications, whether it's a operating room and remotely perform surgery or an autonomous vehicle. Latency is going to hurt us. 80%, again, of your network failures are from the infrastructure and poor installation techniques. And that's caused by this, and that's where we come into play, right? Damaged cables, kink cables, excessive bends, particularly with fiber optic cable, poor termination, non-standards compliant cabling, some of that with the counterfeit listings, dirty fibers, bonding, grounding, you name it, a list of those. And both of these are appropriate tools. The one on the right is good troubleshooting, but that's not going to tell you if your cable is suitable for power over Ethernet or very low latency connections versus the one on the right, which is standards compliant from 568C.2. It's $10,000+ versus a couple $100, right? So this is the standard. So when a customer is handed over a certified cabling system, they got the test results like that. So that's the expectation. Again, the contractor usually does the link from the outlet to the patch panel. They hand it over, and the customer IT takes it from there, plugs in the equipment, and that covers the channel. But oftentimes the channel is done by a contractor for a design build application, or they're doing services. They'll touch the end equipment. And oftentimes what you have is stuff like this. Am I right, IT guy? Oftentimes this happens just because you just plug and play and the lights come on, but they have no knowledge of code standards or best practices, but that is part of the system that impacts latency. Ideally, it would look like this. Proper cable management practices. Hey, you look at that and instills confidence that your network's going to work. I mean, if you have some surgery going to be performing, you want the bio of the physician, you might want to look above the ceiling and in the telecom room. In the future, again, fiber optic cable, dirty connectors, just to be real quickly, the human hair is about 100 microns. Where the light travels is called the core. In this case, that's 9 microns for single mode. So it just gives you a scope of how small that is, and that's where the laser beam travels for your networks. But you could just see the simple things from like a technician rubs the dirt from the connector with their finger and they leave oil on it and it's covering where the light travels. Or they wipe it off on their clothes, or even a speck of dust could be larger than where that light travels. But that happens all day long, even among professionals. This application, I've seen these, whether it's in a DOD or a bank or in a substation where there's dust caps left off, they take them and plug them right in, and there's issues. Common code violations that we see, again, is this unlisted cable, that's the outside cable. Let's say a fiber optic cable or copper, they can't enter the building more than 50 feet. They could extend it if it's in intermediate or rigid conduit, but we see that all day long, where they bring that in and there's 50 feet or hundreds of feet. It's not listed for inside like that. Abandoned cables, if it's abandoned, it's got to be removed or tagged for future. But have we seen for communication, what's the future of a legacy cable? It's no longer recognized, so the future is really just an excuse to not remove it. The future is for a pull string, but it just adds to the fuel load, and which adds to another problem, a cable's resting on ceiling tiles, right? They're supposed to be properly supported. There's been stories of firefighters dying in fires because the ceiling collapses and that unbundled cable, they get entangled in cabling that wasn't properly supported. Those are issues, but that happens a lot. Damaged cables, right? They'll over-cinch it with tie wrap and they've kinked it. That hurts the performance. There's a move to Velcro or hook and loop because it's hard to over-tension those. A pulling tension, that copper cabling that we have here, 25 pounds is the force, and it's very easy to kink it. And remember, these are home runs. They could be 300, almost 300 feet, and so sometimes it's a trick, not a trick. There's some strategies to pull those in one piece without kinking them or bending them, but this stuff happens all the time. And then the bottom left, you see that red glowing on that yellow cable. That's a fiber optic cable with light escaping because it was over kinked, and that should be replaced. And here's a Another one, fire stopping, right? You have to restore the fire rating of that wall. That left-hand picture, they left the tag, which is appropriate. It said the fire stopping is not just putting that red goop in there. It equates to a UL system number. Every manufacturer is going to tell you, it's going to ask you some questions. What are you penetrating it? What's the type of wall? And it gives you a recipe, so to speak. This one says, it's hard to see, WL whatever, which equates to their cut sheet. It's very easy for a fire marshal to ask for a UL system and validate that was done properly. But you can see someone came in after them and put a hole right through that UL system number and didn't restore the rating. But fire stopping is an issue that we address a lot. And of course, Las Vegas, a big issue. I think MGM Grand years ago didn't have proper fire stopping, and a fire went through multiple stories and was fatal. Cables of wet locations, right? These are, the plenum riser is not suitable for wet locations. The NEC defines it when it's in contact with earth. So now you're delivering power, you have a damaged cable under there in contact with water. It's potentially dangerous. And a big one, we see this a lot, splices are not allowed in horizontal cable, and it won't pass the test, and it impacts latency, and these are standards, non-standards compliant, but this happens a lot. So that's the question. It's not just telephones and fax machines. We're potentially having surgery on the network. And again, IT can do with refreshing your screen, but in operation, latency is. So we're redefining life safety with these new applications. So apologize if I ran late. Thank you for your time, and I look forward to working with you. All right.
Hey, Jeff, can I ask you a real quick question?
Yes,
We have a minute.
you bet.
I know you made this presentation at the NASCO meeting, but I had a question. So for us that have my house 20 years old, it was smart wired, it has the old cables that come in from the cable company, or else we can use DirecTV or whatever. So are we going to at some point have to replace those cables in the house in order to get better efficiency on our internet service?
Yeah, I think that's a judgment call for each individual and what they need it for. And really, you have to determine how hard it is to retrofit. My house, I've got a basement that I could access the joist and drill in there. Otherwise, you can drill holes and, otherwise you could take your nice house and staple cables to the outside. So there's ways to do it, but some retrofits are always hard. One thing now, wireless does provide a solution, right? With, one example was with T-Mobile and 5G. Imagine now having T-Mobile for one phone bill for you got your cell phones, and I've got my house, fixed wireless. It's happening. So, wireless is an alternative, but it really, I think, it depends on how hard it is to retrofit and be aesthetically pleasing. I retrofitted my house with wiring, but it was fairly easy with access in the attic and the basement. So it depends. Hope that answers you.
So Jeff, that was fascinating. Thank you very much. And also thank you for diving in, Joe. I think that's really a good conversation. Are there any other board members who'd like to comment?
Jeff, real quick question. Seeing everything you had is great. It was amazing. And I'm from San Francisco, so I know about the cars and stuff like that, and I see it all the time. But my question is, what about, you have the doctors and everything else. What about hackers that can get into a system? How are they deterring that from happening? Because I would really feel weird if somebody was going to operate on me and it was a robot and
You bet.
she was going to hack into the system, and I'm not coming back out now. I was pointing at you.
Yeah, no, it's, we had a good presentation yesterday from the state of Arizona. It was a CIO about cybersecurity practices. So some of them are the use of encryption. Like when my kids go to grandma's house, they aren't asking for the quality of water. They say, hey, grandma, what's your password for your Wi-Fi? And then they say, oh, you need a stronger password, grandma, right? Or, hey, this thing's wide open. A lot of people, let's say those 16 devices in the home network, people unpackage it from Best Buy or whatever, they plug it in without even looking at encryption. So they're wide open. But I think the encryption practices, constantly having good, what was the thing? Length of the password is better than the complexity, or the link is inherently complex. So encryption, passwords, and rely a lot on your IT folks for patches to the systems, constant updates, and even your mobile devices, right? When Apple gives you, hey, it's time to update, they're probably recognizing there's a patch. and they get in. We recognize also for the people doing the work, they could put your network at risk unknowingly. Like if you remember the Target store breach a few years ago, like $40 million. The hackers came in through the HVAC contractors badging system. What Target didn't do was they didn't separate their HVAC from the point of sale system. So they got in through the badging system and got access to the point of sale. So I think for installers as well, contractors are probably one of the number one requested new levels of coverage, cybersecurity, corporate IT. And so it's a long story, but it's probably well deeper than my expertise. We have an IT folk person back here, but it's encryption and constant review of that and updating passwords. And country of origin. When we look at, for the DoD, for example, every project now from the concept phase, they want a cybersecurity person. Not necessarily a Cisco security person, but someone that can review all the systems, that to look at the vulnerabilities, and that you have an action plan to address it. Because I mean, if you have there are some buildings with 20,000 devices on the network. And so HVAC, all those sensors, if they're connected, it's a door. I mean, you could buy electrical panels now with a network connection on it. So they look at country of origin, who's the owner, what's the cybersecurity plan, and you carry that over through the construction period and then over the life of the system. Yep.
Thank you. Any other board comments?
Yeah, I'd like to say something about robotics. This is Jacob here. So, technology, you mentioned at the beginning about the in-ridge electric truck, how robotics is now taking over, human jobs, right? And we're seeing this a lot, especially in our world, right? I know my kids play with the VR and have those senses, right, when they put these goggles on. We go to the market stores these days, and, there's not a human there anymore to take, your payment, right? Last week I was at a hotel where there was no one there. I just walked in, scanned, and it replaces, right? In construction, we're seeing robots now, robotics coming in where, these robots are replacing what a journeyman would take probably, 3 days. It'll do it in 20 minutes, right? Now we're seeing more technology where robots, dogs, I've seen a dog the other day that's coming out there doing layout work for us. Robots are actually placing drywall and actually physically installing, what humans are doing. So are we taking account on that aspect of how, if one single robot, right, this, you mentioned this electric truck, how many people it's going to put out of work, right? And, we see it in the ports, right? In the ports of Long Beach, we've seen that where the robotics came in and it eliminated a whole group of people that used to perform that work. So what's our thought behind that, and who polices, also the safety factor that we're always concerned in the construction industry about, OSHA, obviously, regulations and stuff like that. Is there anybody, or who's the people that oversee all that?
Yeah, I don't know who's overseeing it. I mean, you're talking a bigger cultural change in like the ethical use of robots. I mean, look at what TurboTax is doing to the accounting business, right? You have an accountant that works with a software script and updates the code. And because of TurboTax and TaxSlayer, there are some high jobs like chemical engineering. Could that be replaced by a computer and algorithms? So clearly, that's a thing. I think culturally, you need to look at that. If people are going to be displaced, then there's other, I think politicians are looking at that. But robots, I mean, we use that already in construction, not necessarily a robot. Let's say something with LiDAR, it could take pictures of a building, so we don't have to take a tape measure and document it. That's happening now. So I think it replaces some of the routine and mundane tasks. So a professional can do more higher end stuff. So there's some value there. I don't think the robots are yet climbing ladders, moving ceiling tiles. So I think for the trades, a lot of them are still valued. I mean, it's a short question. I know that I don't have the answers. I don't know that we all, but it's upon us. It's like the iRobot movie happening in real time.
Thank you. Any other board comments or questions? Thank you, Jeff. That was terrific. What an interesting. So for the next item, we're going to do a discussion regarding the Nevada Contractors Board and the California Contractors Board operational and structural comparison, including board member composition, budget, license population, license fee schedule, criminal background checks, insurance requirements, exam waivers with other states, and consumer restitution programs. Nevada Executive Officer Margie Green and Registrar David Folk will take the lead on this agenda item.
Significant points on the chart before you, pages 10 and 11 in your board book. Our annual budget last year was just over $7 million, and our current staff size is 54 employees. During last fiscal year, we received over 2,395 new license applications, which is up about 3% from the prior year. We issued approximately 1,300 new licenses, representing a 12% decrease over the previous fiscal year. Our license renewals were also up 2%, with over 7,600 active and inactive license renewals being processed by staff. Our active license count is up by 348 from last year, with 17,416 licensees, while our inactive license count is up for a total of 509. We continue to utilize more than 400 PSI testing centers nationwide and recognize 12 states as part of our licensure by endorsement program. Moving on to some of our enforcement statistics, approximately 66% of complaints received during the fiscal year were against licensed contractors, with the remaining 712 complaints against unlicensed contractors. 39 licenses were revoked, and our Residential Recovery Fund Committee considered 85 claims. Among those claims, 77 were approved and awarded with a total value of $767,000 during our fiscal years. Since inception, the Residential Recovery Fund has awarded over $14.2 million in claims to harm homeowners. That concludes the Nevada's overview, but I'd be happy to answer any questions that anyone has. Otherwise, I'll turn it over to Mr. Folk.
You have a question. You said you have 400 PSI locations nationwide.
Yes, we do.
Is it like one per state or just a couple per state? With PSI, do you have the ability to say how many you want in each state, or is it just a market
I believe it's
price?
wherever the PSI has the testing centers located. Is that correct, Ms. Mathias? Nancy Mathias is our licensing administrator, so she would be more appropriate to answer.
Yes, thank you. For the record, Nancy Mathias, Nevada State Contractors Board. We allow our candidates to take an exam at any PSI testing facility throughout the country. So if they have an authorized test facility, that candidate can schedule there, and they will deliver our exam electronically to them.
Was that a significant, well, I guess it would be a little bit more, but was it a significant difference in price than just keeping it in Nevada, or was there a lot more money that you had to pay for nationwide?
We have a no-cost contract with PSI, so the candidate pays the exam fee directly to them. We do not handle that. So it did not cost the state any additional money, and it provided a service to our candidates whereby they didn't have to travel to Nevada if they were located in another state.
Thank you, Ms. Mathias.
Margie?
I have one, Michael Marker, I have one question. The question is in terms of the restitution or recovery fund. Is it mainly for residential? And that's what it sounds like, right? And then I guess the follow-up question is solar included for that?
Yes, Mr. Mark, thank you for the question. It is all residential construction. Residential contractors pay an assessment into the fund, and those are only awarded to, those claims can be awarded to owners of single-family residents who contract with a licensed contractor only.
Is
And
there
it includes
a
solar.
maximum per case? I don't know. That seems interesting to me because for us, it sounds like a lot of the issues that we have consumer-wise is on the residential end, so.
Yes, there's a maximum award per individual of $40,000, or a maximum per contractor, an aggregate amount of $750,000, or 20% of the recovery fund, whichever is less.
And I guess, did I hear correct? Each contractor that does residential is the one that's paying into that fund, and it's a pool of money. And then does your board actually does the payout and as like an arbitrator, I'm assuming?
Correct. They pay an annual assessment based on the license limit that they have. It's only residential contractors. And then we have a subcommittee, the Residential Recovery Fund Subcommittee, which they meet usually every other month, and they award the grants or award the claims, determine if it's a legitimate claim or not, and the payouts are from there. So,
Thank you. Sounds like a good program.
thank you, it's a great program.